Chapter 6, Factors and Multiples. In the previous class, we have studied the concept of factors and multiples. Here, we will extend further the concepts. The two main concepts that are covered simultaneously at the primary school level are factors and multiples. In contrast to multiples, which are multiplied by another number to produce particular numbers, factors are the numbers that divide the given number exactly. Now is the time to review the idea of multiples and factors of a number. Factors and multiples. Factor. A factor is a number which divides the given number completely by leaving no remainder. For example, 3 into 4 is equals to 12. 3 and 4 are factors and 12 is product. Every number has a common factor, that is 1 and the number itself. Multiple. A number which can be expanded as a product of two or more numbers is called the multiple. Multiples can be observed in a multiplication table. 24 is the multiple of 1, 2, 3, 4, 6, 8 and 12.
We have to write all the factors of 8. We know that the factor for all the number which is common is 1. So after 2, 2 is the factor of 8. Now 3 is not the factor of 8. 4 is the factor of 8. 6 and 7 are not the factor of 8. And at last 8 is the factor of 8. Now all the factors of 10 is 1, which is the factor for all the number. Now 2, not 3, not 4. 5 is the factor of 10. Now at last 10 is the factor of 10. All the factors of 14. So 1, 2, not 3, not 4, not 5, not 6. 7 is the factor of 14 and at last 14 is the factor of 14.
Properties of factors. In a division with no remainder, the divisor and the quotient are factors of the dividend. For example, 27 divided by 3 is equals to 9. Here, 3 and 9 are factors of 27. The largest factor of a number is the number itself. For example, 15 is a factor of 15 itself. The smallest factor of every number is 1. For example, 5 divided by 1 is equals to 5. 10 divided by 1 is equals to 10, etc. Every factor of a non-zero number is less than or equal to the number. For example, among the factors of 20, 1, 2, 4, 5 and 10 are less than 20 and 20 is equals to itself. Every number except 1 has at least two factors, namely 1 and the number itself. For example, 3 has the factors 1 and 3 and 5 has the factors 1 and 5. Properties of multiples. A number is a multiple of itself. For example, 6 is the first multiple of 6. Every number is a multiple of 1. For example, 1 into 1 is equals to 1. 1 into 2 is equals to 2. 1 into 3 is equals to 3, etc. Multiple of a non-zero number is either equal to or greater than that number. For example, the multiple of 5 is equal to 5. Second, third, multiples are greater than the number 5. Every number divides its multiples exactly. There is no end of multiples of a number. For example, multiples of 3 are 3, 9, 12, 15, 18 and so on. Even and odd numbers. Even numbers. Counting numbers which are exactly divisible by 2 are called even numbers. For example, 0, 2, 4, 6, 8, 10 and 12 are even numbers. Odd numbers. Counting numbers which are not completely divisible by 2 and leave the remainder 1 are called odd numbers. For example, 1, 3, 5, 7, 9, 11 and 13 are odd numbers. Tests of divisibility. Test of divisibility by 2. A number is divisible by 2 if its unit digit is any one of 0, 2, 4, 6 and 8.
720 has 0 in its last. So 0 is even number. Hence it is divisible by 2. So 720 is divisible by 2. Any number which is even is divisible by 2.
Test of divisibility by 3. A number is divisible by 3 if the sum of its digits is divisible by 3.
Now again we'll check 720 is divisible by 3 or not. So for this we calculate the sum of the digits, which is 7 plus 2 plus 0, which is 9. 9 is purely divisible by 3, hence we can say that 720 is divisible by 3.
Test of divisibility by 4. A number is divisible by 4 if the number formed by its last two digits on its extreme right is divisible by 4.
Now we are checking the divisibility of 4 on 720. For checking the divisibility of 4, we'll take the last two digits, which is 20. We can say that 20 is divisible by 4, hence because it is a multiple of 4, so we can say that 720 is also divisible by 4.
Test of divisibility by 5. A number is divisible by 5 if its unit digit is 0 or 5.
Checking the divisibility of 5 on 720. We can see that 720 has 0 in its ones place. So we can say that 720 is divisible by 5. Any number which is having zeros on its extreme right is divisible by 5.
Test of divisibility by 6. A number is divisible by 6 if it is divisible by each one of 2 and 3. Test of divisibility by 7. To test the divisibility of a number by 7, double the digit at ones place and subtract it from the number formed by the rest of its digits. If the number obtained after subtraction is divisible by 7, then the given number is also divisible by 7. Test of divisibility by 8. A number is divisible by 8 if the number formed by its last three digits on its extreme right is divisible by 8. Test of divisibility by 9. A number is divisible by 9 if the sum of its digits is divisible by 9. Test of divisibility by 10. A number is divisible by 10 only when its unit digit is 0. Test of divisibility by 11. Test of divisibility by 11. A number is divisible by 11 if the difference between the sum of the digits at odd places and the sum of the digits at even places is either 0 or a multiple of 11. Prime and composite numbers. Prime numbers. Prime numbers are natural numbers that can only be divided by 1 and by the number itself. In other terms, prime numbers are positive integers greater than 1 that have exactly two factors, 1 and the number itself. 2, 3, 5, 7, 11, 13 and other prime numbers are just a few of them. Never forget that 1 is neither a prime number nor a composite number. For example, 2, 3, 5, 7, 11, 13, 17, 19, 23, etc. are prime numbers. Composite numbers. A composite number has more than two factors, which means apart from getting divided by the number 1 and itself, it can also be divided by at least one integer or number. We don't consider 1 as a composite number. For example, 4, 6, 8, 9, 12, 14, 15, 16, 18, etc. are composite number. Note: The smallest prime number is 2 and it is the only even prime number. To find all prime numbers between 1 and 100. The ancient Greek mathematician Eratosthenes developed the method of finding prime numbers up to 100. This method is known as sieve of Eratosthenes, which is discussed below. Step 1. Cross out 1. Step 2. Encircle 2 and cross out the remaining multiples of 2. Step 3. Encircle 3 and cross out the remaining multiples of 3. Step 4. Encircle 5 and cross out the remaining multiples of 5. Step 5. Encircle 7 and cross out the remaining multiples of 7. Step 6. Now encircle all the remaining numbers. All the encircled numbers are prime numbers and all the crossed out numbers except 1 are composite numbers. Thus, all prime numbers between 1 and 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. Twin primes. Two prime numbers are called twin primes if there is present only one composite number between them. We can also say that two prime numbers whose difference is 2 are called twin primes.
For example, 3 and 5, 5 and 7, 17 and 19, 29 and 31, 71 and 73, etc. are all pairs of twin primes. Co-primes. Assume that x and y are two positive integers and that they are co-prime numbers if and only if they share only the number 1 as a common factor, with the result that HCF of x and y is equals to 1. The highest common factor HCF of co-prime numbers or a group of numbers or integers is 1, making 1 their only common factor. For example, 5 and 9 are co-primes. 7 and 11 are co-primes. Example number 1. We have to separate out composite and prime numbers among these numbers. So, we know that prime numbers have only two factors, which is 1 and the number itself. So, firstly, checking 12. We know that 12 have many factors like 1, 2, 3, 4, 6 and 12. So, 12 is a composite number. Now, for 17. 17 has only two factors, that are 1 and 17 itself. Hence, it is prime. For 20. 20 has many factors like 1, 2, 4, 5, 10, 20. So, it is composite. Now 36. 36 again has many factors like 1, 2, 3, 4, 6. So, it is composite. Now for 41. 46 have only two factors, which is 1 and 41. So, it is prime. For 92, we can see that it is a prime number, so it already had 2 as its factor. So 1 is also a factor of it, 2 is also a factor, 4 is also a factor. Hence we can say that it is a composite number. Prime factorization. Prime factorization is the process of identifying a number's prime factors so that the original number can be equally divided by them. Since a composite number, as we know, has more than 2 factors, this method only applies to composite numbers and not to prime numbers. There are 2 methods of finding prime factorization. First, division method, and second, tree methods. First, division method. The steps to calculate the prime factors of a number is similar to the process of finding the factors of a large number. Follow the below steps to find the prime numbers of a number using the division method. Step 1. Divide the given number by the smallest prime number. In this case, the smallest prime number should divide the number exactly. Step 2. Again divide the quotient by the smallest prime number. Step 3. Repeat the process until the quotient becomes 1. Step 4. Finally, multiply all the prime factors. Firstly, we can see that it is a even number, so let's divide it by 2. So it is 38. Now again it is a even number, again divided by 2, it will become 19. Now 19 is a prime number, so it can only be divided by 19 itself, hence it becomes 1. Therefore, it can be written as 76 is equals to 2 into 2 into 19. Tree method. To find the prime factorization of the given number using factor tree method, follow the below steps. Step 1. Consider the given number as the root of the tree. Step 2. Write down the pair of factors as the branches of a tree. Step 3. Again factorize the composite factors and write down the factors pairs as the branches. Step 4. Repeat the step until to find the prime factors of all the composite factors. In factor tree, the factors of a number are found and then those numbers are further factorized until we reach the closure. Suppose we have to find the factors of 80 and 480 using a factor tree. Then see the diagram given below to understand the concept. We have to write the prime factors of 80 using the tree method. So it will goes like, now 80 is an even number, so we'll divide it by 2 and we'll get 40 as a result. Now again 40 is an even number, so the smallest number we can divide it by is 2 and we'll get 20 here. So again 20 is an even number, divided by 2, so we'll get 10 here. Now again 10 is an even number, we'll divide it by 2, we'll get 5 here. 5 is a prime number which can only be divided by itself, so we'll get final 1 here. So the prime factors of 80 are 2 into 2 into 2 into 2 into 5. So these are the prime factors of 80. Highest common factor HCF or greatest common divisor GCD. HCF of 2 or more numbers is the greatest common factor of the given number which can be divide the given numbers without leaving any remainder. It is abbreviated as HCF and also known as the greatest common divisor GCD. HCF by factorization method. To find the HCF of 2 or more given numbers, we proceed as follows. Step 1. List all the factors of the given numbers. Step 2. Identify their common factors. Step 3. Identify the largest number in the list of the common factors, which is the HCF of the given numbers. We have to find the HCF of 54 and 84. For this, we have to write the factors of 54 and 84 separately. So the factors of 54 are 1, 2, 3, 6, 9, 18, 27 and 54. Factors of 84 are 1, 2, 3, 4, 6, 7, 42 and 84. Now selecting the common factors here, 2, 3, 6, only this much. So the common factors is equals to 2, 3, 6. We can also write 1 here. So the highest factor among these factors is 6. So we can say that the HCF or the highest common factor of 54 and 84 is 6. HCF by prime factorization method. we can follow the below given steps to find the HCF of numbers using the prime factorization method. Step 1. Write each number as a product of its prime factors. This method is called here prime factorization. Step 2. Now list the common factors of both the numbers. Step 3. The product of all common prime factors is the HCF. Use the lower power of each common factor. Let us understand with the help of examples. Now we have to find the HCF of 56 and 88 using the prime factorization method. Find out the factors of 56. So it is a even number. Let's divide it by 2. We'll get 28. Again by 2, 14. Again by 2, we'll get 7. Now it is a prime number, so we'll divide it by itself only. So we'll get 1 here. Now let's take 88. It is an even number. Let's divide it by 2. We'll get 44. Now divide 44 by 2. We'll get 22. And again by 2 we'll get 11. 11 is a prime number. So we'll divide 11 by 11 itself. So we'll get 1. So the factors of 56 is equals to 2 into 2 into 2 into 7, and factors of 88 is equals to 2 into 2 into 2 into 11. Now the common factors is equals to, this is common, this is common, and this is common. So 2 into 2 into 2. So the product of this is 8. Hence we can say that the HCF of 56 and 88 is 8. HCF by common division method. To find the HCF of the given numbers, we proceed as follows. Step 1. Arrange the given numbers in a row in any order. Step 2. Divide the numbers by the lowest common factor. Write the quotient below the numbers. Step 3. Again, divide the quotients by the lowest common factor. Step 4. Repeat the process till there are no common factors to divide by. Step 5. The product of the divisors is the required HCF. Now we'll find the HCF of 36 and 80 using a common division method. So we'll write it as 36 and 80. These both are even numbers, so we'll divide it by 2. It will become 18. It will become 40. Now again by 2, it will become 9. It will become 20. Now on dividing, now this is odd and this is even. We cannot divide these two numbers with a common number. So we'll stop here and we can say that the HCF of 36 and 80 is 2 into 2, which is equals to 4. HCF by division method. This method is used to find the HCF of large numbers. To find the HCF of the given large numbers, we proceed as follows. Step 1. Divide the larger number by the smaller number, obtain the remainder. Step 2. Divide the divisor by the remainder. Step 3. Repeat the process of dividing the previous divisor by the remainder last obtained till 0 is obtained as remainder. Then the last divisor is the required HCF. Now we have to find the HCF of 75 and 180 using the division method. So let's divide 180 by 75. So it goes like 75 into 2 is 150. We'll get 30. Now divide this 75 by 30, which goes like 30 into 2 is 60. So it will become 15. Now divide 30 by 15. It will become 15 into 2 is 30. Therefore, we can say that HCF of 75 and 180 is 15. So this is the final HCF. Least common multiple, LCM. The LCM of two or more given numbers is the smallest common multiple of each of the given numbers. A common multiple is a number which is a multiple of two or more numbers. Example number 1, find the LCM of 12 and 18. So firstly we'll write the multiples of 12 and 18 separately. So multiples of 12 is equals to 12, 24, 36, 48, 60, 72, 84, 96, 108 and 120. Now writing the multiples of 18, 36, 54, 72, 90, 108, 126, 144, 162 and 180. So the common multiples are 36, 72 and 108. So the least common multiple among these is equals to 36. Hence, LCM or the least common multiple of 12 and 18 is 36. LCM by prime factorization method. To find the LCM by prime factorization method, we proceed the following steps. Step 1. Resolve each of the given numbers into product of prime factors. Step 2. Take the common prime factors occurring maximum number of times. Thus, the LCM of the given numbers is the product of all different prime factors. Now we have to find the LCM of 65 and 78 using prime factorization method. So let's find the factors of 65 first. Divided by 5 will get 13. Now 13 is a prime number, so it will get divided by itself only, so we'll get 1 here. Now 78 divided by 2 will get 39. On divided by 3 will get 13, and again 13 will be divided by 13 itself. Therefore, LCM of 65 and 78 is equals to 5 into 13 into 2 into 3, which makes it 390. Hence, 390 is the LCM of 65 and 78. LCM by short division method or shortcut method. To find the LCM of the given numbers by using short division method, we follow the following steps. Step 1. Write the given numbers in a horizontal line, separating them by commas. Step 2. Divide them by a suitable prime number which exactly divides at least 2 of the given numbers. Step 3. We put the quotient directly under the numbers in the next row. If the number is not divided exactly, we bring it down in the next row. Step 4. We continue the process of step 2 and step 3 until all co-prime numbers are left in the last row. Step 5. We multiply all prime numbers by which we have divided all the co-prime numbers left in the last row. This product is the least common multiple of the given numbers. Now we have to find the LCM of these three numbers using the short division method. Now let's find the factors of 96, 108 and 180. Let's divide it by 2. We'll get 48, 54 and 90 here. Now these three again will be divided by 2. We'll get 24, 27 and 45. Now these three are common multiples of 3. So let's divide it by 3. We'll get 8, 9 and 15. So this number comes in the table of 2 and these numbers are multiples of 3. So let's divide it by 2 first. So it will become 4, 9 and 15 as it is. Now again divided by 2. Now again by 2, 9 and 15 as it is. Now divided by 3 now. It will become 1, 3 and 5. Now by 3, 1 and 5. Again by 5. Now by 5, 1 and 1. So the LCM is equals to, multiply all these numbers. We'll get 2 into 2 into 3 into 2 into 2 into 2 into 3 into 3 into 5, which becomes, now take all the 2's together, which makes it 2 into 2 4, 4 2's are 8, 8 2's are 16, 16 2's are 32, 32 and all the 3's together, 3 into 3 is 9, 9 into 3 is 27 and rest is 5. Now multiply these numbers. This will become, on multiplying, this will become 4320. Common facts about HCF and LCM. Two numbers are said to be co-prime if their HCF is 1. The LCM of two co-prime numbers is equal to their product. If one number is a factor of the other number, then their HCF is the smaller number and their LCM is the larger number. Product of two given numbers is equal to the product of their HCF and LCM. That is, first number into second number is equals to LCM into HCF, or LCM is equals to first number into second number divided by HCF, or HCF is equals to first number into second number divided by LCM. Example number 1. Now we have to find the greatest number that divides these numbers on leaving 1, 3 and 5. So we have to find a common divisor which divides these numbers after leaving 1, 3 and 5 respectively. So the number becomes 55 minus 1, that is equals to 54. 84 minus 3, that is equals to 81. And 140 minus 5 is equals to 135. Now we have to find a common divisor for all three numbers. Now using a common division method, 54, 81 and 135. Let's divide these numbers by 3. We'll get 27 and 45. Again divided by 3, we'll get, again dividing by 3, we'll get 6, 9 and 15. Now divided by 3 again, we'll get 2, 3 and 5. Thus, we get 3 into 3 into 3 is 27. Thus, we get 27 as the greatest number that divides 54, 81 and 135.